Hi kids, video 20 is about forces and motion. How do we sort of go back and forth between these two big ideas that we've learned in physics? The essential question is, how are the motion of the object and the forces acting on the object interrelated? So the first thing I'm going to do is just lay out the big picture of all the things that are kind of interconnected with each other in this realm of forces and motion. We have this equation, A equals sigma F over m, and the A sort of leads you to the motion side of that equation, and the F, sigma F, is the forces side of that equation. So under motion, once you know the acceleration, there's a whole list of things you can find given some additional information that you probably are given in the problem. So for example, usually you're given something about the time, although if you weren't, you could find it using acceleration. Or you could find change in velocity, right? They're together in that other acceleration equation. So once you know acceleration, you can get change in time or change in velocity. Once you have change in velocity, if you're told the initial or the final velocity, you can find the other one, because change just means the difference from the final minus the initial. Once you have the initial and final velocity, you can use those together to calculate the average velocity, and often the last thing that you're calculating in motion is the actual distance the object has covered while they're accelerating. So all of those things are available to you once you know the acceleration of the object. On the other side, we have forces, and that equation notably gives you sigma force, okay, the total of all of the forces. From there, you're often going to start by, throwing that force on a free body diagram, or looking at what you know about the object and the interactions that are happening around it. And you can use sigma force in your free body diagram often to find the values of several of the individual forces, which tells you something about the fundamental properties of the objects, how big they are, or what the surfaces they're rubbing on are like. So on the forces side of this equation, we can learn a lot about the surroundings and what's going on with the object. So you can see with that one equation, we've got a whole huge list of variables that are related that you can often solve for using tools that you've developed in the last couple units. So I'm going to run through a couple sample practice problems with this. It's going to take a while, especially if you do it right. So my preference here is that you are going to pause the video and actually attempt to solve it. There's been a lot of data that's shown that the more practice you actually have at solving problems, the better you are. So I hope you'll not just listen to me run through the solutions, but instead actually grab a calculator, grab a pencil, and do your best to solve this problem. So an example might be a 75 kilogram cheetah can reach a velocity of 30 meters every second from rest in 3 seconds. What else can you learn about the motion or forces acting on the cheetah from this information? So I didn't ask for anything specific. I'm just saying calculate everything you can possibly calculate for the sake of this problem. First thing I would always do is generate a no list. So please pause the video and write your own no list based on the stuff in the problem before you check what I said. Okay, so hopefully you did that. I'm back. These are the 4 variables that I would have put down as no. I know the mass, I know the initial velocity of 0 meters every second. That one's kind of hidden in there, but it says from rest, so that's actually something that should go on your no list. I got my final velocity, and I've got the amount of time it takes. Next thing is to come up with a list of all the things we could solve for. Feel free to pause the video and take a shot at this also. The list of things that I came up with that we could solve for are the average velocity, the distance covered, the change in velocity, the acceleration, and the sigma force. So these are the order that I would solve these things in, because sometimes solving individual problems gives you more known values that you can use to solve other problems. So if you want kind of a roadmap of how to solve this problem, that's the order I would solve those things in. And if you could pause the video now and give it a shot, then on the next slide I'll walk you through all the solutions. Okay, So when I left you, we had this no list of those 4 values. As you'll see in a minute, as we solve things, we're going to generate additional known values that we might have to use in further equations. So the first thing I would do is find the average velocity. In general, to find the average, we just take the sum of the initial and the final and divide by 2. So when you did that and plugged in, you should have arrived at a V average of 15 meters every second. The second thing I would do is find the distance covered, and I've put the equation down there for you, which hopefully you found on your own, but in any case, there it is. And the solution, when you've plugged in your values, is 45 meters. The third thing to calculate is the change in velocity, so delta V, or V final minus V initial. You got to keep track of all these different V's, right? We have initial, final, average, and delta, and they're all going to be different values. In this case, when you plug into that V average equation, or delta V equation, you get, again, 30 meters every second because we started at rest. The fourth thing is the acceleration. And the equation I would use is the definition of acceleration, which is delta V over delta T, because now we know a delta V and we already had a delta T. So when we plug in and solve, we get an acceleration of 10 meters per second every second. And the last thing I solved was sigma force. My equation is A equals sigma force over M. When you plug in and solve, you get sigma force is equal to 750 newtons. So that means the cheetah has an unbalanced force of 750 newtons acting on it as it accelerates. Give yourself a pat on the back if you got through all this stuff on your own. Okay, now we're going to run through a forces to motion problem, which is kind of the same kind of idea, but in reverse. So the example problem is we have a 3,000 kilogram elevator, which would mean it has a force of gravity of negative 30,000 newtons. And it has a maximum velocity of negative 18 meters per second when it is descending or going down. We have brakes attached to ropes on the elevator that have a maximum tension of 34,000 newtons while it slows before the ropes break. So the question is, what can we learn about all the forces and the motion of the elevator while braking to a stop? So again, I didn't tell you exactly what I wanted. I just want you to solve for everything you can possibly solve for. So the first step is going to be generating your no list. So pause the video, look at the problem, and generate your no list. I came up with 5 values for my no list: the mass, the force of gravity, the initial velocity, the final velocity because it's slowing to a stop, right? And then tension. My want list is lots of other things, but in the order that I would find them, first I would make a free body diagram, then I would solve for sigma force, acceleration, delta V, time, average velocity, and finally the amount of distance the elevator is traveling. Okay, so I'm going to walk you through these problems step by step. There's my no list. The first thing I would do is draw my free body diagram. There are 2 forces in that free body diagram: gravity acting downward, negative 30,000 newtons, and tension acting upward. That's the way the rope is pulling on the elevator at 34,000 newtons. A couple things to note: this is an unbalanced free body diagram. This elevator is going to be accelerating. The extra force is upward, which should make sense because the elevator is going downwards and slowing down. So we should have acceleration in the opposite direction from the motion. The next thing I would solve is sigma force, so the total force. And you can figure that out in this case, not by the equation. Sometimes you use the equation, but in this case you have all the forces right there on the free body diagram. So you just have to look at that free body diagram and figure out how much total extra leftover force is there. I did that by adding those 2 forces together. So when you plug it in and solve, you get sigma force of 4,000 newtons left over. Now I'm going to go into that acceleration equation and use the sigma force to solve for the acceleration. So this is like the reverse of what we did in that last problem, right? We started with acceleration and got to sigma force. Now we're starting with sigma force and getting to acceleration. When you plug it in and solve, you end up with an acceleration of 1.3 meters per second every second. The next thing I would find is the change in velocity of the elevator, delta V, as it's slowing down to a stop. So in this case, remember that it's final minus initial. We're going to have a delta V of positive 18 meters every second, right? We changed by positive 18 because we started at negative 18 and ended up at 0. From here, we're going to find time. And the way we're going to find time in this case is by using our acceleration equation, because we know delta V and we know acceleration, so we can find time with that equation. When you plug it in to solve, this is that tricky cross-multiply situation, so if you're not sure how to get to that final solution, set it up as 2 fractions and cross-multiply, but you end up with an answer of 13.8 seconds. This would definitely be a good one to run yourself with your own calculator to make sure that you can do that cross-multiplying step. Then I'm going to find the average velocity, realizing that average velocity is just the sum of the 2 velocities divided by 2. So in this case, my average is negative 9 meters every second. And the last thing you can figure out is how much distance that elevator is covering while it is slowing down, using your V average as delta D over delta T. When you plug in and solve, you find that elevator moved. Actually, there's an error on that. It should be negative 124 meters. But that hopefully is what you came up with on your own. Okay, so if you made it through the whole video, kudos to you, especially if you actually did pull out a calculator and solve those things yourself. I know you're going to be much better prepared for our exam if you did that. The essential question was, how are the motion of the object and the forces acting on it interrelated? And hopefully you saw lots of different ways that we can go back and forth between forces and motion. Thanks for watching.